basically a binary number system where two consecutive numbers defined in only one bit. What I mean by this, let's implement this practically. So now that here, I will make a table of which we will do to, there will be a binary code. Let's see how a binary code works. So at here, binary code. Let's take an example of 5 and 6. Here, you like the value of 1, 0, 1, and at 6, 0, 1, 0. Alright. Now, what we're going to do, we're going to, as you can see here, the decimal, this is decimal, this is equal to the binary code. Now let's see that how many bits have changed at this point. So let's see. First, 1 bit have changed and it converted to 1 to 0. Then another bit have changed, 0 to 1. This have been same, 1 1. This have been same. So at binary code like here, 2 bit will change. Now let's exactly see if we write the exact thing on gray code, what will happen. Let's make a demo really quick. Alright, so if we write the exact of 5 and 6, let's see. The gray code 1 and should be 0, 1, 0. Now at this point, as I told that at this point 3 bits have changed. And if we move to gray code, in these 4 bits, this have not changed. So the only bit have changed, which is this, which was converted 1 to 0. So at this point it was 0 1 1 1, and then when the bit changed, it was 0 1 0 1. So what it means that at binary code, maybe 3 or 4 bit can change, or at gray code only 1 bit changes. Now let's take another example to better understand this. Binary. So I just want to do 7 and 0 1 1 1 and 1 0 0. Now, as you can see at this binary table, at this point 3 bit won't change. And I have told that only 3 or 4 bit can change this binary. Like as you can see, this bit have changed, it has also been changed, and it also been changed. So let's be 4 bits will change. Now let's slide the exact in gray code what will happen in gray code. So exactly 7 and 8. Then we write the numbers of the code 0 0 0 and stand by do this. Now as I have told in gray code only 1 bit changes, but in binary it depends on the bits. So now 7 and 8 0 0, this has not been changed. The only have changed was this bit right here. So that's what I mean by that this gray code is called as unit distraction. unit. Second is that this is also called as reflected code. And also known as minimize minimum error code. So by this is a unit saturated, second reflected code, and minimum error code. Now let's move on to that what is gray code in practical life user. Let's take some examples. The first is digital computers. It oh, actions. And this includes it also includes TVs and such things like TVs and electronics. Systems also used in lottery encoder and sequential encoder. It includes more things such as TV and electronics, stuff like this. So, yeah. Sequential encoder. Now, let's understand that how to convert a binary code into a gray code. Such as, so let's take an example of a number in binary as 0, 1, 0, 1. Alright? So now, first of all, to convert a binary code to decimal, there are 3 steps. The first The first is that the first step is to the G key, which will be gray key, is equal to the B key. I will spell this letter. Now the second, the G2 is equal to the B2, which we use the XOR table, which will be used practically this. So I'm just writing the steps. Now I explain this what I mean by this. And third, you have to repeat this. So before we start converting, as you can see the sign right here, this means XOR table. So let me make an XOR table very quick. And the values. And yeah, now you got the values right here. 0, 0, 0. If the values are same, the output will be same. If the value is not set, the output will be 1. Same as here. So if the values are not set, the output will be 1. If the values are same, the output will be 0. That's how it works. Now, what we will do that we will now implement this like here. How? First, let's understand what I mean by G tree and B tree. Okay, so this like here, this is called as the MSB of binary number. But what is MSB? So MSB stands for most significant con yeah, so it's the most significant. And now let's understand it what I mean by B3. So B3 is the most significant number of binary code which is after B2, B1 and B0. And the G3 is the most significant and the most highest number of gray code. Let's do this. So at this point, at the first step, it's the G3 and is equal to B3. So what it means that this 0 is equal to the gray code. Now, and here, what we do, that we XOR. We look at XOR table. If the values are not same, what is the value? So if we come here, I have like an XOR table. If the value is 0 and 1, the output is 1. That means this will be 1. Now, if this 0, so if the output are not same, what will happen? The value will be positive, which means 1. Now, same as here. If the values are not same, 0 and 1, we XOR, we look at XOR table right here. So this is 0 and 1. 0 and 1, which is equal to 1, which means this will be 1. So that's what this is our gray code right here. Now, to better understand this, let's have one more example on exactly on this. Now, we will have a table of 1, 1, 0, 0. Now, what will we do? We will do the exact same. We look at the steps. G3 is equal to B3. So, as this will be exact what this will come. So, if the values are same, if the values are same, the value is 0. If the values are same, the value is 0. Which means this is 0. If the values are not same, the value will be 1. If the values are same, the value will be 0. That's how it works. And yeah, that's it. Now let's do the exact on gray code. Now let's do this was the binary to gray code. Now let's do gray code to binary. How does that work? Stand by. So if you want to do gray code to binary, what you have to do that gray binary. Alright, how it works? Exactly 3 steps. First step is the B key. Now at this point the gray was equal to B, and at this point the G key, the B key, which is the most significant binary number, is equal to the most significant number of gray codes. So these B key and G keys are equal. Second step is to the B2 is equal to B3 XOR G2. Alright. Now, in the third step is repeat. Repeat. Repeat these steps. example of 1, 0, 0, 1. Alright. Now at this point, let me give some space for the labels. So yeah, 1, 0, 0, 1. Now let's label this with, as for gray code we use G3, G2, G1 and G0. Now here here BT is equal to a GT, so this will be exactly same. Now at this point, if you can see it here, we got XOR in 0 and 1 like this. But at this point, what we're doing right here is we will XOR like this. So we will see that 1 and 0. So if we look at XOR table, if it's 1 and 0, if the values are both same, the output will be 0. The output will be 1. Now, if we come here, 1 and 0, what will happen? The output are the output are not same, so it's 2 1. If output are same, it will be 0. So the answer is 1 1 1 0. So this is the gray code and this is the binary code. You have converted. Now to better understand this, let's again do some practice on this. So so yes, that's it for this video. Thanks for watching.